Okay guys, so now we are going to go into the nitty-gritty, the banyak part, which is chemical properties of your alcohol. So here we have the different reactions your alcohol can go through. Okay, this is the reactions of alcohol when your alcohol act as weak acid or proton donor. Then there are two types of cleavage. The first type of cleavage is awak potong dekat OH bond. Okay, so then your H will be eliminated. So this one you have the reaction with sodium metal. Okay, or you have esterification. Maksudnya buat apa ni? Buat ester lah, buat sabun, buat perfume, whatever. Okay, and then here you have the second type of cleavage, which is the cleavage at the RO bond. Okay, this is when your alcohol, it acts as base or the proton acceptor. So in here you will you will eliminate your OH. Okay, it is the process of dehydration. Obviously you will buang OH dengan H, buang water, or substitution reaction with haloalkene or haloalkene HX, okay, acid PX3. Okay, where your X is Cl atau Br, or PCl5 or SOCl2. Okay, ini simple je. The difference is that what byproducts that you will form. Okay, ini second type of reaction is oxidation reactions. So oxidation reactions of alcohol, you can use different types, two types of oxidizing agent, whether they are strong or mild oxidizing agent. So different oxidizing agents will give different products. Okay, kalau guna strong, awak akan dapat something like carboxylic acid or ketone. Okay, when you use mild you will get aldehyde or just ketone. But this one also depends on the class of alcohol and your oxidizing agent. Okay, and then you have identification test. Okay, Lucas reagent is to determine the class of alcohol, while iodoform test is to detect the presence of methyl carbinol. So we will look apa benda methyl carbinol tu. Okay, alright, so let's start with the first type of cleavage, which is when your alcohol acts as acid. So that means that it will donate your hydrogen. So there will be a cut here, cleave at the OH bond. So an example of reaction that you cut at OH bond is when you react with sodium metal. Okay, so here you have your alcohol ROH. Okay, so I wrote it as RO bond H. So when you react with sodium, RO minus will attach to your positive charge sodium, and you will get sodium alkoxide. Okay, and you will also get hydrogen gas as the byproduct. Okay, so you cut here. So ini jadi the minus, ini jadi plus, this is the plus. So this one tukar dengan ni. Boleh? Okay, so these are examples. So if you have ethanol reacting with sodium, you will gantikan this hydrogen with an E. Okay, so you get this salt. Bukan salt. No, alkoxide. Okay, sodium alkoxide. Sodium ethoxide. Okay, here pun sama. Okay, you have two OH there. So you cleave the OH bond. Okay, and then gantikan H ni dengan sodium. Okay, gantikan. So dapatlah the sodium alkoxide and hydrogen gas. Alright. So reaction macam ni, if dia kata macam it will form sodium alkoxide with byproduct hydrogen gas, so awak tahulah this is reaction of alcohol with sodium metal. Okay. Next reaction where you cleave your OH bond is esterification. So there are two ways for you to form esters. That is by reacting carboxylic acid with alcohol, okay, or reacting acyl chloride with alcohol. Okay, so beza dia, ini carboxylic acid, ini acyl chloride. Okay, tapi dua-dua awak akan dapat ester. Tapi different byproduct dia. For when you react carboxylic acid with alcohol, you will get water. You remove water. Tapi bila react acyl chloride with alcohol, you will get acid as the byproduct. Okay, sebab acyl kan, acyl chloride kan, so Cl ni awak buang ni, HCl ni. Okay, so let's see for the example for formation of ester using carboxylic acid and alcohol. Let's say if you use propanoic acid and methanol. Okay, so tengok alkohol, bila nampak je carboxylic acid dengan alkohol, awak tengok awak punya alkohol, awak cleave dia punya OH bond. So H ni akan kena ganti dengan siapa? Ganti dengan this part of your propanonic acid. Okay, ni OH minus ni akan react dengan H ni. Okay, so ini dengan ini akan form water. This one will sambung with this. Okay, another way for you to remember this is that ini adalah delta plus, ini adalah delta negative. Okay, and then you have this one as your minus, and this one is your positive. So the opposites will attract, so that's why H will go with OH to form water, and then this part of alcohol will sambung dengan this part of propanonic acid. Okay, so the name of your ester, okay, will be methyl propanoate. Propanoate comes from the carboxylic acid. Propanoic acid jadi propanoate. 8 sebab dia jadi C double bond O, CO minus. Okay, methyl ni daripada methanol, this part. Okay, so sama je sini. Propanoate 8 tu sebenarnya COO minus ni di sini. Okay, and then you will get water. Okay, so here when you form ester using acyl chloride and alcohol, let's say if you have ethanol chloride and methanol. Okay, look at your methanol, the cleave is at OH right here. So ini the negative, ini plus kan. So yang ni kat sini, this will be the delta plus right here. This one will be delta negative. So bila acyl chloride dengan alcohol, you will remove HCl. Okay, you get HCl as the byproduct. So these two, yang ni akan sambung dengan yang ni. Okay, so nama dia sama juga macam tadi. It will start with your alcohol. Okay, methanol ni jadi methyl, denoting this part methyl, and then ethanoate. Ethanoate datang daripada your acyl chloride. Okay, kenapa dia panggil ethanoate? Sebab ethane, F maksudnya 2 carbon, OH maksudnya COO minus. Okay, and you will get byproduct HCl. So that's the first type of cleave. Second type of cleavage is cutting the RO bond right here. So ini adalah bila awak eliminate OH. Okay, so in the dehydration of alcohol, maksudnya awak akan buang water kan. So the adjacent carbons, so first what you going to look at is, do you have adjacent carbons with hydrogen atoms? So here you have your carbon, okay, alpha carbon, and then you are going to look at the carbon that is attached to this carbon. So awak ada satu je carbon in this case, so maksudnya awak memang akan buang this hydrogen lah dengan this OH, and then you will form an alkene. So your alkene will be 1, 2, 3. Macam ni. Betul? Awak dah buang water. Okay. So, kalau yang ni pula. Okay. Awak tengok awak punya alpha carbon ni. The one that is holding the alcohol. Okay. Apa apa carbon yang attached to it? So you have this carbon, you have this carbon, you have this carbon. So these two carbon ni, kalau buang hydrogen dia sama je lah produk dia. Kalau buang yang ni, lain pula produk dia. Okay, bila buang yang ni, one of the hydrogen. So macam nak tahu, your product will be like this. If you buang daripada this carbon, hydrogen, macam ni. Betul lah. Betul lah. Okay, dapat this alkene. Dengan lagi satu. Apa? Ni ada CH3. Buang OH dari sini. Let's say buang dari sini. You will get this. So for this one, for this case, maksudnya awak boleh ada major dengan minor product. Betul tak? So yang ni awak kena ingat lah, guna Sazaf rule. So awak keluarkan possible alkenes that you can form. So the major product will be the alkene with more R groups attached to its carbon-carbon double bond. Okay. So next you have substitution reactions. Ini pun akan cleave at the RO bond. Okay. So when you react with HX, it can be HCl, HBr or HI. Okay. You will form a haloalkane with byproduct water. Okay. So selalunya for cleave at OH ni bila awak form bila awak eliminate water lah. So here you are going to cut this bond. Okay. Then cut this bond. So that means that this OH will be diganti, will be replaced by this Br. Okay. What type of reaction is this? Substitution reaction. Okay. So dapatlah haloalkene awak. Ini water yang dibuang ni. Okay. For example, okay, the Lucas test or Lucas reagent. Okay, bila awak nak find out the class of alcohol. So this is an example lah using Lucas reagent. So you have to react with concentrated hydrochloric acid in the presence of zinc chloride. Okay, ini specific Lucas reagent ni. Tak ada HBr, tak ada ZnBr2 Ini Lucas reagent. Okay. Okay, and then you have these other substitution reactions. Okay, kan saya cakap tadi yang substitution reaction ni semua awak dapat haloalkane. Okay. Specific haloalkane lah, depending on the reagent. So if you use PX3, where PX3 can be PCl3 or PBr3, sama juga, you will cleave at OH. So you'll gantikan, substitute OH with your X. So in this case, let's say I use PBr3, I will get RBr. Okay, the difference between these reactions is that I get here phosphoric acid. Yang atas tadi, bila I guna HX, I get water as my byproduct. So if I use PCl5, okay, cleave here, okay, gantikan OH dengan Cl, dapat haloalkane RCl. Okay, but my byproduct will be POCl3 and HCl. Okay, ni kena ingat lah. Okay, ni kena ingat dia punya byproduct. Itu boleh jadi hint untuk soalan juga. Alright, reactions. So if I react my alcohol with SOCl2 in the presence of pyridine, ingat kena ada pyridine. Okay, I will get RCl, gantikan OH ni dengan Cl1. Okay, and my byproduct will be SO2 and HCl. Dapat dari mana ni? SO2 HCl. Okay, macam tu lah. Yang ni awak memang kena ingat. Okay, ingat dapat haloalkane. Bila nak form haloalkane, boleh react alkohol dengan any of these reagents. Okay, alright.